And as usual, I use the term loosely. Most of these videos I make stem from a process that I plan on performing on a customer's engine or bike. And I usually think ahead of time and say, oh, this might be interesting, let's do this, or let's do it this way and video it. This is none of those. This is an accidental video. Furthermore, it is a video that has been 40 years in the making. And what it has to do with is a set of flywheels, a customer flywheels I'm working on right now that have proved very, 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 very difficult to true up. Dick with them for several hours, couldn't get anywhere. And that led me to finally finish something that I started 40 years ago for the same problem. As it turns out, many moons ago, I was working on a set of flywheels off of a flathead 45, and they refused to true up correctly also. What I did at the time was I had an old crankpin, and I started making a gadget like this out of it. And my idea was that I was going to make a crankpin with the shaft on it, and I could use the taper on the crankpin to lightly lap the taper and the flywheels, and hopefully restore it to true. Anyway, 40 years ago, I had this old flathead crankpin, and I made this, or I almost made this. I wasn't quite done with it for whatever reason, and I don't remember why I never finished it. I was working at the time at a place where the guy happened to have a lathe and some milling machines and stuff like that. It really wasn't a mechanic shop, but it had machinery. So I started making this tool out of an old flathead crankpin. And like I said, I never finished it. And this thing banged around in my toolbox for, 20, 30 years. And, after a while I says, that was a nice idea. Too bad I never got around to finish it, and I pitched it, okay? Well, just the other day, as a matter of fact, I was working on these flywheels right here. And I had these flywheels in and out of this truing stand 20 times, messing with them one way or another. I actually had loosened the shafts up, shifted them around, loosened both sides of the crankpin, shifted it around. I could not bring these things into true. And like I say, messed with them for quite a while. Before I took them apart to lap the rod bearings, as is my practice, I put them on the truing stand, in the as delivered to me condition to see how bad they were. And the runout on them was about 10,000ths of an inch, which was pretty bad. On a lot of the flywheels that I pull out of an engine, I'll put them on here and the runout is 3 to 5, 6,000ths, which is way over the limit. But, a lot better than 10. It goes without saying. But anyway, I could not bring these guys in. And finally I decided, after a little bit of experimentation, that the problem was with the taper on the sprocket side wheel. And what I decided I wanted to do was to resurrect the taper lapping tool that I started on 40 years ago and give it just a try to see how it would work. I'll show you how this works in a minute. But anyway, I made this thing and started working on these. And just as a point of reference, let's zoom into the dial indicator. Watch the needle. Did you see it move? If you did, you got damn good eyes. Messed with these things for 4 hours. Spent an hour making this, probably 3 minutes using this. Reassembled them, put them back on the truing stand. 2 adjustments were performed, and at the end of 5 minutes, I've got the runout on these things down to about a little less than a 0.5 of an inch, 5/10,000ths. So this is very good. We'll go out in the dirty shop. I'll show you how this thing works. And I don't know, it might be something I'm going to add as standard procedure from now on. But anyway, I'll show you how it works. So let's go out in the dirty shop. We'll take a look at it. Okay, so here's the setup for using this tool. This end, the shank was turned down to just about exactly 3/4 of an inch so that it could fit in a 3/4 inch collet. So I just pop it up in there, snug it down a little bit. And I put maybe a fingerful of 320 grit valve grinding compound. You don't need a lot. That's probably plenty. That's way more than I need, as a matter of fact. I'm not going to use all that. Just kind of smear it around there a little bit. And we'll turn the mill on. And that's all she needs. So just hand feed a little bit in there. And this is not the flywheel you saw inside. This is just some other flywheel I had laying around. And just a few little pumps, and that's all I did to the one that's in there. And that made all the difference from a wheel that was impossible to true into a wheel that trued up in like 5 minutes almost perfectly. I may do this to all of my flywheels that I rebuild from now on out. It's so easy, it's so quick, seemingly it does a lot of good. There are some people, and I've read about this over the years, there are some people who say the little bit of roughened surface with the lapping compound leads to a better grip of the pin in the wheel. Ideally, you probably want to use the crankpin you're installing in the motor, but this is over an inch in diameter, and I don't have a big enough collet to use an actual crankpin, which is why I had to make this tool. But anyway, that's all there is to it. And like I say, it went from impossible to true to almost perfectly true in 5 minutes. Can't beat it. Highly recommend it. Be very careful. It doesn't take much. And if you do decide to make your own version of that tool, and I probably could have made it out of a piece of steel and just duplicated the taper on the pin, but I had a pin, why not use it? This is what I used to cut it. Those pins are case hardened, and judging by the way they cut, they're probably about 80 thousandths of an inch deep with the hardening. And I use a carbide bit, and as you can see, this bit has been broken and ground on, and actually this works really good. Carbide is typically these edges are kind of rounded over, and for work on a small lathe, they don't necessarily always cut real nice. But when they got to the point where they won't cut at all going through the hardened surface, I put them on a grinder and grind back a little bit of relief on the top, and modify the angles and such a little bit to reestablish cutting edge. And this actually worked pretty good. So once you get through the case hardening on them, this actually produced a pretty nice finish. That's the one that this tip that's showing here is the one I did the finish cuts on. So you bastard. Focus. There we go. So this tip here is what did the finish cuts on it. So anyway, that cut pretty good, and that's the finish it generated. For the purposes of this tool, that carbide cutter did a pretty good job. Very happy with this. I'm going to keep this thing, and I plan on using it some more. Stay still. There we go. Anyway, that's the tool. Okay, one other little demo I want to do, as long as I got you here. and we're talking about flywheels. The crank pin nuts, the shaft nuts are all tightened to 150 foot-pounds. They're tightened down where they're going to go. They're not going to get tightened anymore. I didn't leave anything loose. You know, people regard this as a pretty rigid assembly, but watch this. Just with hand pressure, I could deflect that needle. So this is not nearly as rigid as people think it is. I got to think when the engine is running, this whole thing, you know, is doing this kind of number as it's, you know, as the engine is running. Every power stroke probably flexes this thing a little bit. It's really more like a big spring than a solid, rigidly cast or forged item. But anyway, something just to be aware of. Not nearly as rigid as you might think it is. I'm going to show you one last thing on these flywheels. You'll notice this area in here has been machined down. There's a little bit of a recess here, okay? 35 thousandths of an inch of a recess. And there's a reason for that. That is because when I torqued the nut on the sprocket shaft, I could not fit a 0.0015 feeler gauge between this flange and the flywheel. And that means that this flange was bottoming on the flywheel, which in turn prevented the taper from seating all the way in to the flywheel. Your strength isn't derived from the nut tightening up against this flange, the big nut on the other side. The strength is derived from the contact area between the taper and the shaft. If this bottoms on the flywheel before the taper is fully seated, you will never fully seat the taper and it will not be as strong of a connection as it could be. I've got a feeler gauge and you'll notice that when I try to slide it in, it won't go in. It's hitting the edge of the sprocket shaft, and it's because the edge of the sprocket shaft is now below the surface of this little cutout that I machined into here. So let's try something. This is going to be hard to demonstrate, but I'll give it a try. Let's see, I got a, let's see. Okay, here we go. Here's a 10 thousandths feeler gauge. And you might be able to see it bend a little bit. You can't see it bend, but see, I don't know, maybe you can see it. Notice it's now deforming down a little bit to fit under there. So I do have a positive gap between that flange and the flywheel. And if I pop it out of there and then try to go back in, I have to kind of force it to get it to make that little bit of a bend. So the purpose of this flange is not to provide a seat on the flywheel for the sprocket shaft. The purpose of this flange is to provide a seat for the Timken bearing. When you tighten your double bearing up, you know, with the big nut on the end of the sprocket shaft, it pushes everything up against this flange. So this is for the Timken bearing seating and not to seat up against the flywheel. Anyway, I do this with a boring bar. It doesn't take too long, and this check is a check I do whenever I put a flywheel together, because you never know. You want it to be as strong as it could possibly be. You know, Lord only knows I don't want this coming apart on my customer. He'll be mad, and I'll have to do it all over again and buy him an engine for free. Anyway, just last FYI kind of gee whiz information. And with that, I am out of here. Hey, thanks for watching. Y'all have a good day. We'll talk to you later. Take fucking 3. The fucking adjustment on the tripod keeps loosening up and the camera keeps drifting, and the image correspondingly goes out of focus because the autofocus doesn't work. What the fuck? Anyway, while rooting around in my junk pile to find a donor crank pin to make this thing, I happened across these guys over here. And it just for your viewing pleasure, in case you've never seen a trashed Sportster crank pin, this is what they look like. This is total bearing failure right here. There were no bearings left in this one, I'm sure, when I took it apart. There were fractured lumps of melted metal, more likely than not. This one here, Similar thing, not quite as bad, but you know, this is not long for the world. And then the last really trash one, I probably got more trash ones, but these were close to the top of the pile. And then this one over here, same thing. The male rod bearing went bad on this one and just ate it up. If you're ever going down the road and your bike makes a noise like marbles rattling around in a can, that's what your problem is. Pull it over, shut it down, because if you don't, you'll be looking at those crankcases with a hole poked in them and a rod hanging out, because that's what'll happen. You'll trash a rod on this thing and it'll bust a hole in your motor. Anyway, just in case you never saw one, there they are.